Fine. Okay, so yesterday's class we had started with the decision tree based algorithms. What are the popular decision tree based algorithms? One is what is called your ID3. Then second one is C4.5, about which we will be discussing today. And there's one more called CART, C-A-R-T, I mean classification and regression trees. Okay, so these are the popular algorithms. Okay, so they all basically differ in how the various nodes are being split or how the splitting attribute is being selected. Okay, so that's how where most of the algorithms differ. Okay, so yesterday we had looked into the ID3 tree construction procedure. Okay, so were you all able to work out the problem that was posted in GCR? At least one problem. Still, I won't get a response. Okay, I'll look into the GCR and find out to myself. Okay, so the splitting criterion which was used for ID3 is nothing but entropy. What was entropy? What was entropy all about? Entropy was basically the amount of disorderness or uncertainty as far as a data set is concerned. Okay, so we always try to reduce the entropy and thereby maximize the information gain. Okay, so we'll just have a recap of the ID3 reconstruction procedure. So in the first step, what do? You compute the entropy information for the whole training data set. Okay, so by using this particular equation, after that, what do? You compute the entropy information for each of the attributes, for each of the attributes in the data set by making use of this equation. This is equation 1, this is equation 2. After that, what do? You compute the information gain. Okay, how much information is gained by branching on that particular attribute. Okay, so that is computed with the formula info entropy for the whole data or for the target predictor variable minus the entropy of the individual attributes. That will give you the information gain for that particular attribute. Okay, so as entropy increases, information gain decreases. They're inversely proportional to each other. Okay, so that is the next step. Then what do? What do you do after that? First, you compute the. Can somebody tell me what is the next step? Initially, you compute the entropy for the whole training data set based on the target variable. Then you compute the entropy for each of the attributes in the training data set. Then you compute the information gain with using this particular equation. Then after that, you select the attribute for which the information gain is the maximum. That means for which the entropy value is the minimum. Okay, so that will be treated as the best splitting attribute. Okay, so you choose the attribute for which the entropy is the minimum. Okay, so that will be treated as the best splitting attribute and that will be placed on the top of the tree. As that will be the root node. Okay, what happened to my pen? Okay, fine. The root node. Okay, then the root node will be branched into subtrees with each subtree as the outcome of the test condition of the root node attribute. So that's how you split the training data set into what is called your subsets. Okay, so then you recursively apply the same operation of the training data set. Okay, so then you continue till the stopping criterion is being reached. What is stopping criterion? When you have homogeneous instances, when the node becomes pure. What is homogeneous instances? When you have all positive values or all instances of negative values in a particular node, or you reach the leaf node where no more training instances are available in the subset. So you continue the same procedure till then. Okay, so that was what ID3 algorithm is all about, and we look into this example. We looked into this example. So first, what we did is we computed the entropy for job offer. Then we started computing the entropy for each of these attributes to CGPA, interactiveness, practical knowledge, and communication skills. This was a predictor variable. Okay, so then we started computing for each. Then we computed the information gain. Information gain for each of the attribute. You can see information gain for uh, uh, CGPA, interactiveness, practical knowledge, and communication skills. So from them, which was the one with the highest uh, maximum information gain? Okay, so that was 0.5564. That was for CGPA. Okay, so based on that, we created a partial decision tree based on the information what we had. Okay, so then from the 10 records, we reduced it to 4 instances. Okay, then we proceeded. The next iteration proceeded with these 4 instances. Okay, these 4 instances. Then again, the same procedure was repeated, based on which we got this table wherein the practical knowledge and communication skills had the same information gain. So the final decision tree can be created with one of these attributes. Either you can go for practical knowledge or for communication skills. So here, for illustration purpose, we have taken practical knowledge and created the final decision tree. Okay, so this was the decision tree based on ID3 algorithm. Okay, so again, one more example was there. This was also posted in the this was also posted in your GCR. Okay, so this you can do it as an assignment, and both can be submitted by tomorrow. So please do it, because the second cycle test will all be problems based on all these things. The third unit is fully problems. Okay, all the algorithms, we have a number of problems. So this is a homework for you. Okay, so now we need to move on to which algorithm. What is the next algorithm we are supposed to be looking into? What is the next algorithm? After ID3, what is the next algorithm to be discussed? At least in the chat window, please put it. What is the next algorithm to be looked into? No one had a breakfast in the class.
C4.5.
Yes, C4.5. C4.5. So we move on to that. C4.5. Okay, right. Okay, so this is actually an improvement. Okay, this is actually an improvement on your ID3 algorithm. Okay, so this ID3 algorithm, whatever we have discussed, it will work well if the attributes or the features are considered as discrete values or categorical values. And the ID3 algorithm, whatever we discussed, it works well for large data sets. Okay, so in case the data set size is very small, okay, so overfitting, an issue called overfitting can occur. Okay, then it is not, I mean, again, if you have missing values in the data set, that is, certain values are missing for the attributes, so again, ID3 algorithm may not give you a correct answer. Okay, and again, and there's a concept called tree pruning, cutting off the branches or removing the branches based on certain criterion. So concept of pruning is not being taken into consideration as far as your ID3 algorithm is concerned. Okay, even during the construction or after the construction, tree pruning is not at all being done. Okay, so it is definitely being prone to what is called your outliers. Okay, so the C4.5, whatever we are going to discuss right now, it is considered as a improvement over your ID3, improvement over your ID3 algorithm. Okay, so this actually works well with your continuous as well as discrete attributes, and it takes care of missing values, and it also supports what is called post pruning, removing and reducing the data set by removing certain branches based on certain conditions. So this is definitely considered to be an improvement over your previous algorithm. Okay, so how it takes care of missing values is, missing values will always be marked with a question mark. Okay, question mark. So missing values are not considered during the calculations. So it is easy to spot and identify the missing values. Okay, so and this C4.5, this is more efficient when you are trying to build decision trees for smaller data sets or smaller decision trees, you can say. Okay, so now coming to the splitting criterion. Okay, so in ID3, we made use of what is called what was the splitting criterion being used? Entropy or information gain. Okay, so here this uses the concept of what is called your gain ratio. Okay, gain ratio during the construction of your decision tree. Okay, so the information gain measure, or the entropy measure, what is being used in ID3, so that is normalized, okay, put into certain range by computing another what is called a split information. Split information, this is important. Okay, so okay, so this normalized information gain of an attribute is what is called your gain ratio. Okay, so the information gain attribute, whatever you had in your ID3, so that is being normalized. Okay, normalized. So the normalized information gain of an attribute is called your gain ratio, and it's basically computed as the ratio of the calculated split information and information gain of each attribute. I'll show you how it works. Okay, so then whatever attribute, just like your ID3, the attribute with the highest normalized information gain. Okay, so that is the highest gain ratio. Highest normalized information gain is nothing but the highest gain ratio. That's what is called gain ratio. Gain ratio is nothing but the normalized information gain of an attribute. So that will be used as the splitting criterion. Okay, so highest gain ratio is used as the splitting criterion. Okay, so how you compute the gain ratio is, see, the gain ratio is equal to, please make a note. So today you are going to work out and give me the answers rather than me giving you all the answers. Okay, so gain ratio is equal to information gain divided by the split information of individual attributes, splitting information of the individual attribute. And how you compute this splitting information is what is being shown here. Okay, so yeah, it is nothing but the information gain of A, attribute A, divided by the split information. Okay, so the split information for a particular attribute, how it is being computed is what is being shown here in the equation. Okay, so again, log to the base 2 and some computation aspects are given here. Okay, so that we will look into by, by working out an example. How you compute the split information. Make a note of the equation what is being given here. Okay, so now we'll do an example. Okay, before we look into the example, the tree construction procedure, the algorithm, the algorithm C4.5 decision tree construction procedure. Okay, so what you basically do is, first you compute the entropy information equation. Okay, so is it the same as the previous one, your ID3? It is. This is the same as the previous algorithms equation. So first step is the same. You compute the entropy information equation for the whole training data set based on the target attribute. So entropy information, the sum of minus pi log to pi. Okay, so after that, okay, so for normalizing, we compute some other information also. So second step, what you're supposed to do is you compute the entropy information equation, information gain equation. So these two are the same as your ID3. Then, of course, something new we have. We have what is called a split information equation, and with the help of that, compute what is called the gain ratio for each and every attribute in the training data set. Okay, so this is where the difference comes. Okay, so please make a note. So these two are the same. Okay, so the entropy information equation with respect to same as ID3. Okay, then this is entropy information equation for each and every attribute. Okay, so then with the help of that, you compute the information gain. Information gain will be equal to entropy information of the target attribute minus the entropy information for the individual attributes. You compute the information gain. Okay, then now we are trying to normalize it. Okay, so by computing what is called a split information, the split information for the attribute is computed in this manner. Okay, so then again you can see it's minus sigma. Okay, please make a note, it's minus sigma. Here it is plus sigma, it's here it is minus sigma. Okay, ai by t into log 2 to the base 2 ai by t. Okay, so with this equation, you compute the split information. Then finally, you compute the gain ratio. Gain ratio of the attribute A, how it is being computed is, okay, so gain ratio of A is equal to information gain of A. Okay, so what you have got here from equation 3, it is equation 3 by equation 4. Equation 3 by equation 4 will give you the gain ratio. Okay, so this is the only additional step coming here. Okay, so in order to compute the gain ratio, which will help you to select the best splitting attribute in the tree, we compute what is called a split information. That's the only difference between your ID3 and C4.5. Okay, after that, based on the gain ratio, and similar to your ID3, you choose the attribute for which the gain ratio is the maximum as the best split attribute. Okay, so then that will be considered as a root node. That will be placed as a root node. Then the procedures are all the same. The root node is branched into subtrees with each subtree as outcome of the test. Okay, then again, the training data set, which is being now as a subset, will be considered further in the second iteration and you proceed with it. Okay, so you recursively apply the same operation till you reach a leaf node or no more training instances are available in the subset. Okay, so now have you understood the difference between your ID3 and C4.5? Shall we work out an example? Yes or no? Nobody had a breakfast even to tell yes. Vithun listening in the class? Vithun not listening. Some response has come. Okay. Yes. Okay. So no voice to tell even a yes, right? So that's what you people sit in the class without having breakfast. That's the reason why you are not able to respond. Okay. So now I assume that all of you have understood this particular algorithm, what I have discussed right now. So let us work out the same example. What we did yesterday using C4.5. Okay, so make use of the information gain of the attributes, whatever was calculated using your ID3 in the following example to construct a decision tree using C4.5. Okay, so now I'll call out the attendance. Meanwhile, I want all of you to start working out. If you want any equations, have you made a note of the equations out here? If you want, you can take a pic of these equations, put it in your class group or whatever, and then start working out the this particular problem. Okay, so everything is the same. So first, what do you do? What will be the first step? C-section Nityashree Narasimhan, can you tell me what will be the first step?
Yes, ma'am.
What is the first step? What is the first step? The first step is you need to compute the entropy information for the whole training data set based on the target variable using this particular equation. So what is the target variable out here? What is the target variable out here? This is the target variable, right?
Yes, ma'am.
Your job offer is a target variable. Okay, based on your CGPA, interactiveness, practical knowledge, and communication skill, you get the target, whether you have a job offer or not, whether the job offer is yes or no. Okay, so that's a target variable. Okay, so All of you start working out. I meanwhile, I'll call the attendance. So no sitting simply. I'll make a note here. You don't respond, I'm going to strike out your attendance. Anirudh,
Yes, ma'am.
Dharani,
Present, ma'am.
Ramharini,
Present, ma'am.
Kalyan Sundar,
Present, ma'am.
Aravind, 17. Aravind is absent today. Okay, 20, Sharan Varghese,
Present, ma'am.
Shakti Priya,
Present, ma'am.
Nishok, 23.
Ma'am, present, ma'am.
Okay, Nishok is very busy these days. The morning also I'm seeing a request from Nishok. Ma'am, please make the assignment for Friday. Why Nishok? Only one, two small problems I gave. That also based on a request I made. One is today and one is tomorrow. Shreya,
Present, ma'am.
Suveda.
Present, ma'am.
Suveda was absent yesterday. Yeah?
Yes, ma'am.
Vishal Bashyam.
Yes, ma'am.
Srimati.
Present, ma'am.
Srimati has started working out the problem.
Yes, ma'am.
Computed the entropy of target variable. No answer comes beyond that, right? 37, Kamini Nityashri.
Yes, ma'am.
Pranav Ram.
Present, ma'am.
Srimati S.
Present, ma'am.
Raja Singh.
Present, ma'am.
Pooja.
Present, ma'am.
Lavanya.
Present, ma'am.
Nityashri.
Present, ma'am.
Sriram.
Chat box.
Chat box, ma'am.
Okay, Sriram, fine. Please do it. Then next is Likita,
Present, ma'am.
Satyamohan,
Present, ma'am.
Sharan,
Present, ma'am.
Aviral Patel.
Present, ma'am.
Aviral started doing?
Yeah, ma'am, doing, ma'am.
Please. Hemavartini. Hemavartini. No response. Ajay.
Chat box, ma'am.
Who was put in the chat box? Wait. Hemavartini is put in the chat box. Okay, fine. Ajay. 71. Ajay, no response. Akshata Saha.
Chat box, ma'am.
Okay. Yeah. Akshata Saha noted. 71 Ajay, I didn't get any response. 80 Karthik Balaji.
Present, ma'am.
Santosh Kumar.
Present, ma'am.
Anand Arun. 115. 115, no response. Rahul P.
Present, ma'am.
Okay. Suhasini Srikanth.
Present, ma'am.
Apurva Ravichandran.
Present, ma'am.
Vitun.
Chat box, ma'am.
Okay. Adityan.
Present, ma'am.
Selvan Niklesh.
Present, ma'am.
Ramcharan. 122. No response. Just a second. 122, no response. 123.
Present, ma'am.
KR Santosh Kumar.
Present, ma'am.
Pavitra Shri.
Yes, ma'am.
Okay. Praveen.
Present, ma'am.
Computed entropy or gone beyond that? Anybody computed entropy? Just put in yes or a no. That's it. I'm not going to ask you the answer. Rakesh, all these sort of problems are going to come for your second CT. Second CT, no theory, only problems. Rakesh. 171, no response. Rakesh hardly comes to class. 001 Nityashree Narasimhan,
Present, ma'am.
Nisho Katiraven,
Present, ma'am.
Abel Prashant, Abel, no response. Preetika, Preetika was there in class. What happened? Kevin Kurian Joseph,
Present, ma'am.
Hiten, Adya. What happened to all the C-section? Adya is present.
Yes, ma'am.
51 is present. So 25 is absent, 28 is absent, 45 absent. Then Jay Vora, 53. What happened to all the C-section today? Kishore?
Present, ma'am.
Kishore, what happened to all these people?
Don't know, ma'am.
Don't know. Sridevi? Sridevi, no. Sridevi, okay, noted. Yash Rai, noted. Jayesh Kumar?
Present, ma'am.
Okay, C-section is planning to come at 9:50 and give me attendance. No attendance. Okay. Right. So fine. So who has computed the entropy? Who has computed the entropy value? No one has computed, huh? At least somebody can put in the chat window who has computed. Are you all getting this answer? When you calculate the entropy for the target class, the job offer? No, why? What is the issue? What is the 7 and 3? What is the 7 and 3? I'm getting
Yes
a
and
different
no, ma'am.
answer. Yes and no. I think 7 yes and 3 no's are there, right? Am I right? Let's see. 7 yes, 1, 2, 3, 4, 5, 6. No, job offer 1, 2, 3, 4, 5, 6, 7. See, target variable 7 yes and 3 no. Out of 10. 171 present, ma'am. Network problem. Okay, you remind me at the end. Again, I have to open the logbook. It's your responsibility. You remind me at the end, Rakesh. Otherwise, you will not be getting it. Okay, so now have you rectified your mistake? So you will land up with a value 0.88807. Okay, then after that, what do you do? After that, what do you do? You start calculating the entropy information. Gain information and entropy information for the different attributes. First, you have to compute for CGPA. Next, you have to compute for interactiveness. Then for practical knowledge and communication skills. Then only you can have a table for comparison to see which is the one with the highest gain ratio. Okay, so first you compute the entropy information for CGPA. Okay, so how do you get this? How do you get this? All is 3 by 4, 1 by 4. In yesterday's ID3 algorithm, I had actually demonstrated how you get it. Do you remember? It's the same. This is the same what you had in your ID3. How do you get this 3 by 4 and 1 by 4? 3 by 4 and 1 by 4. For the attribute CGPA, it has to be compared with the target variable, right? How many offers? Job offers, yes or no? I'll show you once again. Where is it? Yeah. See, for the CGPA, there were 3 categories: greater than or equal to 9, greater than or equal to 8, less than 8. For this, for the target variable, how many yes and how many no is there? So that's why we call it as entropy information of T comma A. T is the target variable. A is our CGPA this time. So totally 4 are there here. Totally 4 here, 2 here. So that's how we calculate it as 0.3243. Okay, so this table I didn't show today because it was already displayed in yesterday's problem. I didn't show it today. Okay, that's how you do it. Okay, fine. So now let's come back. Okay. Then the information gain. Information gain, this is the gain of the entropy of your target variable minus entropy of your CGPA. That will give you how much information is gained by branching CGPA. And after that, you compute the split information. Split information of the target with respect to you, the attribute under consideration, that is CGPA. Using the formula, we'll end up with this value. Okay, we will end up with this value. Then after that, you compute the gain ratio. Gain ratio. So it's straight away a division. You get 0.3658. Okay, so this is all the various parameters computed for the first attribute. Similarly, compute for the second attribute, interactiveness. I'll give you a minute. Just check whether you will get the same answer. You don't have to do it manually. You can use your calculators and do it for interactiveness. Interactiveness with respect to your target variable job offer. Same way you prepare a table. Interactiveness where job offer is yes and job offer is no. That's how you get these values: 5 by 6, 1 by 6. Okay, so you are supposed to be getting the gain ratio as 0.0939. Okay, then you start computing the gain ratio for the third attribute. Third attribute, that is practical knowledge. Okay, so you will end up with this value. Okay, so then after that, for communication skills, this is for communication skills. Okay, communication skills, when you do, you'll end up with this. Okay, so all the four attributes we have computed. Okay, so now what shall we conclude? What can we conclude from here? CGPA, gain ratio of the various attributes are given here. So what can we conclude from here? What can we conclude from here? Or how do we proceed, or how do we select the attribute to be at the root node, or the best splitting attribute?
Highest gain ratio.
Highest gain ratio. Very good. Okay, so accordingly, CGPA will be selected as the one with the highest gain ratio. Previously also for ID3, we selected the one with the maximum information gain. So which will help you to reduce the entropy, the disorderness or uncertainty of the system. Okay, same way out here we have what is called the gain ratio. So the one with the highest gain ratio, right? Fine. So CGPA will be on the, so this is the partial decision tree based on CGPA at the root node. Okay. So these two are homogeneous. Homogeneous in the sense you had all instances of yes here and no here. So which means it becomes, these two becomes a leaf node. Okay. So the other branching attribute will be greater than or equal to 9. CGPA. This was the same as your ID3. Just like your ID3, you will end up with this, the partial decision tree after your first iteration. Okay. So now we have these. Okay. That is interactiveness, practical knowledge, and communication skills. Okay. So based on this, we should proceed with our next iteration. Okay. So from a data set of 10 records, we have reduced to a data set of 4 records now. Okay. So next iteration proceeds with this. Okay, so you repeat the same procedure for the resultant data set with 4 data instances. Okay, so 4 data instances, you have only 4 records out here or 4 rows out here. Okay, so the job offer has 3 instances as yes and 1 instance as no. So you can see here 3 yes and 1 no. Okay, so compute the entropy for the target class, wherein you will get an answer as 0.8112. Then repeat the same procedure. So that is for these attributes. Okay. Now CGPA is there at the root now. So now we need not consider that. So now we have to consider interactiveness, practical knowledge, and communication skills. Okay. So you compute the gain ratio for interactiveness, the same procedure. Okay. Compute the entropy information, then the gain, the split information, then you compute the ratio of it. Okay. So which will give you the gain ratio. Okay. Then the next is practical knowledge, and communication skills. So these are the 3 attributes to be considered now. Okay, so finally we get this. We get this table. So now what do we do? Now what do we do? Praveen, what do we do now? Praveen, what do we do now? Practically do nothing, right? We don't do anything now. Sriram, what do we do now? Sriram has left the class after the attendance, is it? So marking Sriram absent. Let me make a note. Sriram is absent, and the next person is Praveen. Both of you are marked as absent today.
I'm here, ma'am. I'm here.
You are here. Praveen is here. No, ma'am, I'm still here. All responses, but at least respond and tell that you don't know then. So who knows what should we do next? It's like I keep on repeating the same steps. You all listen to the same steps or don't listen to the same steps. Finally, no response from anyone. So which one shall I select now? Which one shall I select? Aviral, which one shall I select now?
Yes, ma'am.
Which one shall I select now? There are 3 attributes along with the gain ratios here. Interactiveness, practical knowledge, and communication skills. Which one shall I select now?
Interactiveness, ma'am.
Why interactiveness? That is the one with the least gain ratio, right? So you should select the one with the maximum gain ratio.
Oh, yeah,
Okay?
ma'am. Sorry, maximum.
Yeah. Fine. So any of these, your practical knowledge and communication skills both have the same gain ratio. So you can select one of these. It's up to you. Okay. So we always select the one with the maximum information gain if it is ID3, or the maximum gain ratio if it is C4.5. Okay. So you can select any of these. Okay. So I have drawn the tree by considering your practical knowledge. See, my final decision tree by choosing practical knowledge. Okay, so how can I extract? This is my final decision tree. So this will easily summarize the data available in your training data set. Okay, same way you can easily extract rules from it. What are the rules which I can extract from it? From this decision tree? By looking at this, I can say if CGPA is greater than or equal to 8, then there is job offer is equal to yes. Or if CGPA is less than 8, that's another rule which I can extract from this decision tree. If CGPA is less than 8, job offer is no. Then if CGPA is greater than or equal to 8 and practical knowledge is good, then I have a job offer. If CGPA is greater than or equal to 9 and if practical knowledge is average, job offer is no. Or if CGPA is greater than or equal to 9 and practical knowledge is very good, then again job offer is yes. Okay, so you can easily extract rules from here. Okay, so that's what I wanted to tell you. Fine. So next, right, the same data set. Same data set. So what if I have continuous attributes? What if I have continuous attributes? For example, let's take the same data set. The same data set. Previously, how was CGPA given? Previously, how was CGPA given in your training data set? It was given as greater than or equal to 8, less than or equal to 8, and greater than or equal to 9, right? It was not given, as a continuous attribute. So now let me give it as a continuous attribute. These are the values of CGPA which is being given. Okay, so these are the CGPA values which is being given. Okay, so how do I take care of this? Okay, so what has to be done is when you have a continuous attribute, like how it is being given, the same data set itself, but then my CGPA values are continuous. So we have to discretize it, okay, by finding what is called a split point, or we can say you have to find what is called a threshold value. Okay, so what you do is you find a threshold value, or let's say a best split point, say S, okay, such that all the values in that CGPA, it will be categorized into 2 sets, such that one category will be having values A less than S and second category will be having values A greater than or equal to S. Okay, so that's what I'm supposed to be doing. Okay, so that I discretize it and bring it to how it was in the previous format. Okay, then only I can work on it. Okay, so in case I'm having a continuous value like what is being given here, you try to find out what is called a threshold point, or this is also called the best split point. Best split point, let me name it as yes. And then what I do is I categorize my set of values in such a way that one category will have all attribute values which is less than S, and another category will have all values which is greater than or equal to S. Okay, so always the best split point is that particular attribute which will have the maximum information gained for that attribute. Okay, so we have some steps for it. For doing this, for doing this, what you first do is you first sort the values in the ascending order. For the attribute for which you have the continuous value, you had CGPA, continuous CGPA. So what you first do is you sort the values in the ascending order, then you remove the duplicates and consider only the unique values of the attribute. You remove all the duplicates and prepare this list. Okay, so after that, what you're supposed to do is you compute the gain for the distinct values of this continuous attribute. Okay, so you have all these continuous attributes now, 6.8, then 7.9, 8.2, 8.5, 8.8, 9.1 and 9.5. Okay, so all these duplicates are being removed and the distinct values are there. So you compute the gain for these distinct values. Okay, so you can see here. So I'm splitting it into two. So you can see this 6.8. I'm putting it into less than or equal to 6.8 and greater than 6.8. That's what I mean to say. Split into two categories: A less than S and A greater than or equal to S. So each and everything you split into two. See 7.9 less than or equal to 7.9, greater than 7.9. Similarly, for all the attributes, you split into two parts. Okay, so 2, less than, greater than, less than or equal to, greater than. Okay, so then then you compute the entropy. You compute the gain for each. You compute the gain ratio for each of this. Okay, for each of these distinct values, you compute the gain ratio. Okay, so you just see. So I'm doing this for the attribute called CGPA. So CGPA. So for which value, the value of CGPA with the maximum gain. So which is the value of CGPA with the maximum gain. So that will be chosen as your best split point or the threshold point. Okay, so from the table you can see which is the maximum one. So you can see here this, the bolded one, 0.4462. Okay, so that is actually, it belongs to CGPA 7.9. 7.9. Okay, so CGPA 7.9 will be chosen as the best split point. Okay, so now we can actually discretize the continuous values of CGPA as two categories. That is CGPA less than or equal to 7.9 and CGPA greater than 7.9. Okay, so now the continuous values are being put into two discrete instances. Okay. Okay, that is the computation is given here. Okay, I was just showing this table. So the computation is given here. Okay, so computation is given here. How you get this 0.9.1935. It's being detailedly given here. So for each you do it and see which is the maximum. So that is where CGPA belongs to 7.9. Okay, so 7.9. So you discretize the value as CGPA discretized. CGPA less than or equal to 7.9 and greater than or equal to 7.9. Okay, so then you can proceed as before. So that's how you proceed with it. Have you understood what has happened here, or what was I discussing? Yes or no, at least in the chat window.
Yes, ma'am.
Only Nityashree understands things in the class. Who's somebody else? What about Shreya? Registration number 24.
Yes, ma'am.
Listening.
Yes, ma'am.
Pooja 50. Everybody will say yes, ma'am, but no response, ma'am. That is a problem here. Okay, so that's regarding. Have any doubts? You can ask me. So today we discussed regarding the last topic. What we discussed was how to take care of your continuous attributes. In case your C4.5 algorithm has continuous attributes, what can be done with respect to it? Okay, so what you basically do is you try to find out the splitting threshold value or a split point. Say yes, and categorize it as attributes having one category will be attributes having less than the split point and attributes having more than the split point. Then you compute the gain ratio, see which is the one which has got the highest gain ratio. Okay, so that the value of that particular attribute will be selected for discretizing the values. Okay, so now we have split our entire CGPA column into two, greater than 7.9 and less than or equal to 7.9. Okay, so that's all for today. So today we have discussed, so far how many decision tree algorithms have we discussed? How many decision tree algorithms have we discussed? All in the air. Ramayana is almost over. If I ask you how is Rama related to Sita, nobody knows in this class. That is the situation. Decision tree algorithm was discussed in the class. How many decision tree algorithms are there? These are the decision tree algorithms. We have around 3, 4, 5, 6, 7, 8 algorithms, out of which your syllabus has these 3. ID3, what we discussed in yesterday's class. Today, we discussed about C4.5, the successor of ID3, which is able to take care of the missing values. So this, I think in our data set, whatever we have considered, we didn't have any missing values. In case missing values are there, it will be represented by a question mark and that will not be used for calculations. Okay, so tomorrow's class will be looking into what is called CART. So CART stands for classification and regression trees. Okay, so once we finish this, if time permits, I'll show you a demo in Veka if you get an extra class. Okay, so these are the other algorithms. So those are interested in learning one step more can look into all these. Okay, you have any doubts on any of these algorithms, you can ask me. We have, I think it's almost time for the next class. Right, so this is the splitting attribute, splitting criterion based on which the decision tree algorithms vary. ID3 uses entropy, C4.5 uses the concept of what is called a gain ratio, and CART uses Gini index. Right, thank you. So no doubts. So let me assume that the entire class has understood everything. That's what I would like to presume. Thank you.
Ma'am, 71%.
Thank you, ma'am.